Sudipta, and I look after Digitay's consulting practice. I'm part of the Swift-Kanban team. And therefore, release planning is done in primarily two different ways. Many organizations would typically have a defined frequency. They would say, I would do a release once every 2 months or once every 3 months. They would have a schedule like that. And then whatever fits into that timeline goes into the release. Or they would plan a release around some critical functionality. So let's say if you need a Thanksgiving release, then they would say, okay, then this is the feature functionality that needs Thanksgiving, and therefore whatever gets fixed in that timeline goes in as part of that release. So that's the two primary ways that we've seen schedule being controlled in this mode of work. And estimation is primarily limited to key work items. Nobody does estimate each and every defect or each and every ticket, but estimation is primarily linked to the more major enhancements or the critical items. The other bucket of the work falls in what we typically understand as projects, which obviously have a defined end date and a defined objective to be accomplished. And flow of work is very typical waterfallish. You start with a scope decomposition, you would then do a task decomposition, you'll build a work breakdown structure, you'll make estimates, you'll then define dependencies, end date in terms of when the whole thing is supposed to end. And obviously we are seeing an increasing agile adoption in both the buckets. Actually, it's not fairly accurate to say it's only in the projects, but typically this is the dominant world of software development as we see today. And therefore forecasting in these two methods, in these two categories, is also quite different. In the keeps mode, in the maintenance mode, things are generally non-committal. Between scope and time, if the scope is committed, then the time is non-committal. If the time is committed, then the scope is kept open in terms of what we can fit in that time. And the key issue becomes is that there is a dominant feeling of an overestimation between the business, between the guys and the guys who are going to build the software. And whether it is between the end user and the internal IT, or it is between a customer vendor equation, this is a very, very dominant sentiment that one sees across the board. And estimation is also determined based on timesheets. One of the key things that the key principles that have been adopted is build project data from your previous projects and use that as the basis for estimating your future projects. The catch is that the actual data from your previous projects is largely based on timesheets, and we have a fair level of inaccuracy by the way that it is used. We all work for 10 to 12 hours, but people across the board generally mostly file time for 8 hours. Or if there is a certain level of human intervention and human subjectivity in terms of how much time is filed in which task. So there is some level of error that actually sets in by the way definition of these. On the other hand, as far as projects go, we will go ahead and forecasting is based on critical path planning, and the entire project focus keeps on making sure that the critical path stays within the deadline. But the key catch of this model is that the schedule, which is the final end date, is an absolute end date, which is very deterministic in nature, whereas at the grassroots level, each and every work item that has been estimated that makes the schedule is fundamentally an estimate, so it is a guess. uh, about the estimation and the estimation bias and the estimation inaccuracy that creeps in whenever we estimate anything, not just projects, but we estimate anything. The other critical problem becomes is that since everything is focused on the critical path planning and how to make sure that the critical path is not slipping, whether it is risk planning, quality, team motivation, all other things become very secondary. Critical path becomes the primary objective of what the project manager focuses on and tries to keep the project on. These are the two methods that we see forecasting happening between the typical maintenance production environment and the typical projects environment. So with that background, let's move quickly to Kanban and just talk about for people who might not be fully in sync with Kanban, but a quick primer. Kanban essentially talks about a few key principles. It starts by talking about visualizing the board in a manner that you see on the left hand side of the screen, where you lay out your stages through which your work will progress, and then you have a backlog where you have set of work items that each of these work items will progress through. It talks about limiting your work in progress in each stage so that you're not multitasking too much. So a typical example would be that, if you have a coding lane, you would set a work in progress limit of, let's say, 10, so that at no point of time you have too many items that are just sitting in the coding lane. It talks about focusing on flow and making sure that bottlenecks are not happening in this system. So in essence, what that means is that if you have a testing team that is getting choked up, there's no point of going on developing and making it feeding for the testing team, because they can't anyway take it more. So everything has to revolve around the constraint and trying to make sure that how the constraint bottleneck is removed. It talks about making process policies explicit. So for example, if you have a ready for development lane or a ready for testing lane, there should be a policy that states that what is ready for development. When can be a card said to be ready for development? Is it ready for development when the UI is available? Is it ready for development when the detailed spec is available? Is it ready for development when the acceptance test cases are available? So what is the criteria that you want to define for that card to move from that one stage to the next? You define policies like that, make them very explicit so that there's no ambiguity and subjectivity left in terms of when a car can move from one stage to another. It talks about feedback from the customer. Obviously, as you are completing your work on a continuous basis, take feedback from your end user and incorporate it back. And it talks about evolve in not move in a big bang manner, but evolve from where you are today in implementing some of the principles of Kanban and slowly adopting more and more of the Kanban principles so that you see the desired result. So it discourages people from making a big bang change from what you're doing today to a Kanban way of working. But you work in an incremental fashion so that you start getting some benefits, and then the team starts adopting additional practices of the Kanban process. So how does Kanban help? The flow of cards is at the heart of the Kanban system, making sure that you're finishing things and piling it up. As the cards flow, the system is able to keep track of the effort or how much time it spends in each lane of the card. Across, comes together every day in the stand-up call and goes over the board in terms of discussing what is where, who's getting bottleneck, who's the choked resource, things like that. The Kanban board is a very, very active and a live board, not that it is incremental, it is updated once in 2 weeks. you keep on updating daily, and therefore it is a very active, live, and an accurate representation of what is happening within the project team at any point of time. Further, because it focuses on reducing multitasking, generally people are working on one card, or max another card if they cannot work on one card because of some technical reasons that we call it as a blocking. But generally, therefore, one can make a fairly simple assumption to say that the time that a card stays in a lane is generally the effort that the card took to get done in that particular lane. So some of the key metrics from a Kanban system and is what we call, and it is plotted using a cumulative flow diagram, as you can see on the right side of the screen now, on the left side of the screen now. The cycle time is defined as the time that the development team took to begin the work and to complete the work, whereas the lead time is the time that it took for the customer to say that I need this job done to the time that it actually went live to the end user. So therefore you can see the cycle time is smaller than the lead time, and as you can see from this cumulative flow diagram, the cycle time starts from in progress and it completes at when the card is ready for deployment. Excuse me. Whereas lead time starts from when it is ready to start working till the time that it is deployed. By definition, if you just think about it, cycle time is the inventory divided by throughput. Throughput means the rate at which cards get finished. So if I have a certain inventory of work that needs to be done, the time taken to complete that inventory of work would be dependent upon the rate at which the work gets done. They're obviously inversely proportional, and therefore for the rest of this discussion we will use them fairly interchangeably as we go forward. Move to actually showing to you how we use a Kanban board and a cumulative flow diagram in being able to predict what the future is going to be. So this is a snapshot of our development board. It's a real life project. This is our project development board. As you can see, we have a value stream or stages defined for the planning process where we do our estimation and speccing, and then cards get picked up for development, and as you can see, test automation, code review, test automation review, validation, and finally they get deployed. So that's a typical snapshot of how our work flows through. By just looking at the board and by looking at the legend, you know that we are doing a lot of user stories which are of yellow color. We have one customer defect which is of a blue color. We have some internal defects here which is a pink color, things like that. So you just get an aggregate view of what's on your plate and what are you working on. So that's not the focus of a discussion, so let's move to the actual cumulative flow diagram. So this is how the cumulative flow diagram looks. And the cumulative flow diagram shows you in this black dark line, which is the border of the archive bucket, which is purple in color, and it shows how the archive lane moved from 50 to roughly about 200 till about the end of 2012. And by the way, since this is a snapshot of the January data from our actual production data, therefore you don't see any further cards between January to March, and so you see a flat line there. But what you see is that I am able to say that my current throughput is 6.14 cards per week. So I'm able to give you, based on my track record of how work has progressed. This is actual data. This is no estimation. There is no guesswork here. There is actual data that tells you that I'm able to finish, and it tells you that if I need to finish my work, and at the current rate, it tells me that the work will get over on 8th of during the week of 8th of April. However, if I do need to finish the work by 31st of March, then it tells me that my throughput needs to change from 6.14 cards to 11.33 cards. And I'll make this slightly more pronounced by saying that don't just forecast or do the prediction based on the cards which are on the board, but also add whatever card is in the backlog, which is still, and I redo this, and let's say I extend the end date a little more to, let's say, May 31st, and I replot my cumulative flow diagram. It tells me that I am currently going at 6.6 cards a week, which is obviously the past data, which will not change. But because inventory changed, or what I am targeting to complete, my required throughput now needs to be at 12 cards. And you can go ahead and obviously you can see that guess what, this my current inventory. But if from 19th of August, let's say, if I do have time till the third quarter of this year, then I can actually go ahead and guess that my throughput can actually come down. I don't need to work at such a fast pace. I can perhaps release some resources or do whatever needs to be done because I have more time available to me. So based on your current rate, you are able to predict where you're going to end with this inventory and where you need to be for this inventory to complete by any desired date, right? As prediction using the cumulative flow diagram. But things don't end there, right? So the question remains that, okay, so you have told me what I need to do, but how do I do that? If whether you want me to improve my throughput and therefore reduce my cycle time, or I need to slow down, how do I go about doing it? Because all that I've shown you at this point of time is just an absolute number, but I have not given you a method to get to that. And that is where we talk about using simulation, using the project board. So the basis of simulation is not estimation. And I actually attended a recent Linda at Agile India 2013, where I attended a session from Linda Rising, and she talks about the topic is obviously very it would spontaneously create a emotion and a passion for discussion in different directions. But she talks about how optimistic we are just what we do to software, but in everything that that happens in real life. She takes this classic example where these are two lines of the same length, but very clearly, if one were to ask any stranger on the road, he would say that the vertical line is longer than the horizontal line. And there are n number of examples that she talks. So estimation is fundamentally inaccurate, and even if by chance one was to make an accurate estimate, in reality there are too many variations out the way it was originally thought to be, right? Skill set available to a team changes, the work profile changes, there are different needs that keep happening, infrastructure things needs change, just too many, or you just plain understood the requirement incorrectly when you estimated, you did not have all the details when you estimated. So the estimate has a very high probability of not being the final reality when you're actually taking it for development. What we know for a fact is that the variation in effort takes a distribution pattern, and you could obviously take, depending upon the project circumstance that you are in, that variation pattern could be different, that distribution pattern could be different, but it will take a probabilistic distribution pattern. So what we do is that we derive a set of base data from the actual work that has progressed on the board. We take the current inventory that is available on the board at this point of time, and we take the team profile that is available on the board at this point of time. We make some simple assumptions. For example, like we ignore the fact that if a card was for 2 days, but one of the developers was absent for a day, it will still show up as 2 days, and we kind of ignore those kind of small deviations, because in the larger scheme of things, it kind of becomes insignificant in terms of percentage variation. What we then do is we run the simulation results so that you can actually evaluate what are the options that you have on the table to be able to get the desired change to your current throughput or cycle time. So instead of just thinking that, okay, if my throughput needs to be doubled and therefore I need to double the number of resources, that may not be the answer all the time. Bottleneck is on one particular lane, there is no point, is in the coding lane, there is no point of adding testing resources. So you need to be able to understand where your bottleneck is happening in the current simulation board, and then be able to simulate what are the scenarios that will help you get to the most optimal configuration so that you can bring your throughput to the desired level. So let's do that, and I'll move to our simulation board. So what you see here is very similar value stream to what you saw in our actual work, where we have a work starts from a ready for development lane. It moves to design, coding, test automation, code review, test. The only thing that we have done is move some of the vertical lanes which were there for better real estate usage on the actual board. We had, not sure if you all noticed, but we had some examples like this, but we moved that into a and then we kind of define that, okay, if I'm in the coding lane, you know, my coding lane WIP limit is 10. This is the effort distribution pattern. It's a simple 3-point estimate that many of the people from the PERT-based planning process would be familiar with. So I have a min effort, a max effort, and a most likely effort, and I went ahead and defined a certain resource profile who is apt for that lane. For each of my lanes, I go ahead and define a team profile, a simple team profile, and I define a simple inventory of how my user stories, defects, issues, tasks are. So it's a very clean definition, and what I see is that if this is my team profile, if this is my inventory profile, and if this is my Kanban board actual data profile, then it helps me to see where my bottleneck is. So as you can see, it tells me that it will take me 1800 plus time units. That work is getting piled up at this point of time in the coding lane. You can see actually on the board cards being piled up in the coding lane, right? and at the same time you also see from the CFD itself that the blue lane, which is the coding and the JUnits lane, the CFD very clearly shows that the bulk of the time is getting spent in this coding lane. So that being the problem, what I'm going to do is I'm going to say, okay, let's come back to the board, and if a designer is available, because I did not see any bottleneck happening at the designer stage, and in most cases designers can do some development. If a designer is available, then in my coding lane will allow the designer also to able to do development. So I go ahead and save that, and I do a similar run, and I would expect that the 1800 time units, as you can see, it comes down to 1400 time units, right? Of choke happening and at the coding lane, but it is still happening. There is no doubt about it that it is still happening. Okay. The other thing now, if you start noticing, is that your functional test automation lane has also started piling up. You see the work piling up here, right? And you see even in the cumulative flow diagram, you see the functional test automation lane, which is the purple lane, work getting piled. Really, if just the designer, if you just had the policy that okay, I will let the designers also act in the coding lane, that would not accomplish as much benefit. And at the same time, you can see that testing, which is the validation lane, things are not getting bottlenecked here. So if I were to take an approach and say, okay, let me go to the board, and to my functional test automation lane, go ahead and say that apart from the developer who's doing my test automation, I could use the tester for test data planning and for test scenario development. So I could do that, and if I do that, I do my run again, right? Work starts, and work now, as you can see, it's come down further. The cycle time has come down further to only 1100 plus time units. And let's see, coding is still taking a bulk of time at this point of time. But now you see that being piled up, right? However, you do see work getting, there's a small bottleneck that is happening in the coding done lane here, which means that the test automation review, the guys who are supposed to pull work from this done lane, they are getting choked. They do not have the time to be able to pull faster. So while I was able to eliminate the constraint from the functional test automation lane, the fact that coding review and test automation review were bottleneck, were still a constraint, it made this work pile up in this done lane, which is the green lane here, as you can see. So we'll do one more scenario, and we'll go ahead and say that okay, let's go to the board, and let me say that the code review can be done by a designer also, and I will also say that a test automation review can be done by a tester. So and when I run it, I would hope that my 1100 time units comes down further, and it does come down to 800 time units, and let's see if work is getting piled up. So I do see work still getting piled up at the coding lane, but I don't see work getting piled up in pretty much any of the other lanes. It is flowing through smoothly, right? So you have reached a point of optimization in terms of giving your policy definitions to say who all can do what all things. You've kind of eliminated all the scenarios, all the constraints there. So now we know that okay, if within my board and go to my resource team and add, and by the way, as you can notice, we reduce from without adding a single more resource to the team, right? So you could do that level of optimization just by saying as a policy level who could do what. So I now come down to the resource side, to the developer resource, and say that okay, let me add my resources to 4. Let me add 4 resources to the team and do the same run, and I'm able to bring down the cycle time significantly to 420 time units. Okay, so in essence, what I'm able to do is I'm able to do this kind of what if scenario. I'm able to say that let's not just focus on it is just easiest to say okay, let's add people if I want to reduce my throughput and increase my throughput and reduce my cycle time. But the question becomes what profile, what type of resource do I want to add, where do I want to add, does it just make sense if I just add them anywhere and everywhere? Should I add 4 people or should I add 10 people? If I went to if you see, with adding 4 people, I have added 424 to let's say 10. I am suspecting that I will not get such a dramatic improvement. Right, so it roughly went down by about 180 time units, but I landed up improving adding significantly additional resources to the team. So you could always go to a customer and say that okay, if I need to go ahead and bring reduce the calendar duration of the project from this to this, I have to add so many more resources at this stage of my work of this profile, and therefore that is the additional cost that is going to be. That this is the price that you need to pay additionally for a crash timeline. Okay, so these are all the kind of scenario planning that you can do, and for work distribution, this perhaps gave you almost the best optimal result, as you can see, because pretty much all the lanes are fairly evenly distributed in this. Right, this is the green lane, which is the automation test review lane. This is the coding lane, which is where the next heavy time concentrations were spent. So you are able to get a fairly evenly spread execution by doing the resource distribution this way. So in summary, what we were able to do is we were able to, and this is just some sample data, but essentially you are able to visually predict, saying how I'm going to be able to make an impact to my overall project completion date, which is nothing but the cycle time, if I make the following changes of what nature, what type, when do I need to do it. Okay. Simulation does also add another aspect to it, which is that what I showed you in the past was just for a single run, right? I just showed you one run in each of the scenarios, and therefore, as you can imagine, there was only one particular distribution pattern that was valid for that one run. But if I were to actually do the simulation over, right, so for the same work pattern, same team pattern, same loading, if I were to do this and just keep on the note of the 243 time units, so 543 time units, I can see that let me just expand the zoom size here. I can see that with 95% confidence, after doing 500 such simulation runs, that I will be able to complete this inventory not in 240 time units, but in 263 time units. My average would be 248. The worst case is 280 time units. So I'm able to go back to my customer or end user with a much greater level of confidence to say, if I commit to 263 time units, 95 of the variations that would happen in my execution based on my actual project flow of the past data. I'm also able to see my utilization data. So I'm able to see my developer is 76% utilization, designer is 77% utilization, and my tester is 73% utilization. So I'm able to see a very, very uniform loading of the team, because as you saw, we let people do multiple things. We were not focused on letting people do only one thing at any point of time. So I got a very even distributed utilization, and one of the things that most of the agile methods would encourage you is to have, so that people are not getting bottlenecked, so that you are able to take variations and you are able to absorb some level of spikes. So it's a very, very optimal planning that we are able to do based on this kind of a simulation pattern. With that, I've pretty much come to the end of the demonstration today, and we'll open it up to question and answers. Ravish, I'm not able to hear any of the questions here.
We are still getting questions.
So one of the questions asked is, what algorithm is used for two algorithms at this point of time? There is a uniform distribution and there is a 3-point estimation. The uniform distribution is more useful for an MPP kind of an approach, or UP kind of a planning. For example, you have an estimate, but you want to say that I would be at plus minus 10% of the estimate. So that is where the uniform distribution is more of use. As you showed, was based on 3-point estimate, and a lot of the PERT guys would typically be using that kind of model. So you can build the algorithm also allows you to build a custom distribution model. Though we have not built it in the UI internally, in the UI at this point of time, but in the future you'll be able to do that also. So one of the questions asked is whether it works with the live Kanban data, and the answer is yes. That is the direction that we're headed to. So what you'll be able to do is actually have a button here on the board. I'm sorry, my screen is not shared at this point of time, but yes, you will be able to existing project from an existing Kanban project. So you'll be able to pick up the team profile, the work profile, the min-max effort estimates for a coding lane or for a testing lane. So you'll be able to build that as an initial data set for the simulation engine, and then be able to change it so that you can do your what ifs. I hope I answered those two questions.
We are getting one more question from Rashmi Gupta.
Go ahead. So the question asked is that how does the CFD predict the time to finish the remaining work? So what we are essentially doing is, let me just so essentially the slope of this line, you are able to see my screen, I presume. The slope of this line is nothing but the throughput line, right? There is the number of cards on the y-axis and the time on the x-axis, and so the throughput is width by time, nothing but the throughput line, and that is what the slope that this line is showing here. And all that we are saying is that depending upon when you want to finish the current inventory, whether it needs to be with a higher gradient or a slope line with a lower gradient. So that's what the current throughput or the required throughput is.
We have one question from Jitendra saying, for which kind of project or development it's most useful, and how can we transfer the waterfall model to Kanban?
Sorry, Ravish, I'm not able.
For what kind of projects or developments or product development this simulation and the product will be useful, and can we convert from waterfall model to Kanban, and how do we do it?
For the maintenance and the production support, or for product development, anything where you are doing is going through a staged development process, right? So you have user stories, and the user stories are going through a development value stream process, and that would bang on fit in this. The one that we are going to extend this to is for the MPP based waterfall kind of projects, which is where the uniform distribution model is going to be, and so that is the next version that we're going to roll it out. But if you are doing any kind of project where work is being built, broken up into smaller user stories, and then the small user stories, so Scrum or anything like that, it would perfectly fit in exactly with that kind of execution model.
Okay, so the next question is from Naved, and question is, this may be very useful for IT industry, but how beneficial is it in construction projects?
How beneficial is it for construction projects? So we have to apply our mind. I honestly don't have an answer for you at this point of time. I would assume that, as I said, that one of the key assumptions of the Agile and the Kanban process thought processes is that work is broken up into smaller buckets for execution. So if you are doing a large-scale construction project that can be broken up into smaller buckets for execution and better planning, then for sure you can apply these principles. If it is at a very large aggregated level where the planning is happening, then it would not fit into this model.
And to add to that, the simulation engine, it has the lanes which are configurable, and because those lanes can represent the various stages of construction project that goes on, like a plinth level or the slab that you are filling in, so that can be different stages of your construction, and when you assign your resources along to it, your primary and secondary resources to it, the simulation engine can predict when and how to apply those resources to the construction project and how soon this can be completed.
Correct. One of the follow-up questions I see is what is the solid line versus the dotted line? The solid line is the required throughput rate based on whatever is the end date that you have given in your filter. So in this filter you can go ahead and define a desired end date, and based on that end date, it computes what is the required run rate, required throughput.
So I think we are done with the questions right now.
Okay. Thank you, everyone. Thank you for joining the webinar today. I hope it helps you give a perspective about how Kanban and how this model of working can help you improve your estimation and your ability to predict, not just on guess estimates that were made, at 3 months, 6 months back, but actually base it on how work is progressing real time with your development team at this point of time. So that was the intent. Yes, Anita, please. Sure enough, I would let our marketing team go ahead and act as the coordination for sharing the presentation. The question was whether the presentation can be shared. Thank you, everyone. Have a great day. Bye bye.